Hello all, this video primarily aims to discuss how can we blend the information of HA into the RGB image. There have been numerous tutorials or methods of a similar kind in the past. For instance, the recent video provides an introduction on how to utilize pixel math. Mix HA into RGB. The basic idea is to subtract R from HA first. Then utilize pixel math to process the remaining residuals. Add it directly to the channels R, L, and B. By controlling the relationship between R and B, the color can be controlled. By controlling the corresponding weights between L and H, you can adjust brightness. This achieves precise control over color and brightness. From another perspective, last year I also proposed a new algebra-based method that is more targeted at multi-channel. For instance, there are 5 channels, 7 channels, and I don't want to treat H as red. How to mix colors in this scenario? However, although these two methods are mathematically very complete, they still have a serious problem. It depends on pixel math. Pixel math has a problem. Each time we can only adjust one parameter. Click OK. Wait a bit, a picture will appear. If unsatisfactory, readjustment needed. Repeat previous steps, basically wait for 5-10 secs. Can only see one round of results. If we could find a way, like a curve substantial preview. Look at 5 or 6 results in 1 second. This will greatly increase our flexibility. And it will increase our limit. Therefore, from this perspective, like Photoshop, or if you can write a PI plugin, maybe the most ideal way. So recently in the group, there are other Big Shots friends. Inspired by, I explored a new, based on Photoshop, I discovered a way to perform superimposition method of mixing HA colors and share it here with everyone. So here we want to use an M42 and the peer. An example like this. Here is a color that has been adjusted, LRGB image. How to adjust the color specifically. We mentioned in previous tutorials, only for demonstration purposes here, roughly adjusted the color. I haven't finished this material yet. A serious article has been published. So this is an RGB image. This is a linear image of H we can see after stretching. It appears like this. Therefore, the initial step is, if we desire to utilize pixel math, now it's time to write formulas. As we want to do it in PS, the first step is to stretch it. Export as TIFF file to export 16-bit with deep color, utilizing 16 bits for maximum color depth. Avoid color breaks. Photoshop cannot read TIFFs with decimal values in the file format. Stretch into non-linear file first, then with 16-bit color depth, save as TIFF file. As an illustration, we have the ability to establish it as an LRGB TIFF file format. Pick 16-bit color. Then extend H initially. For instance, utilizing the most basic stretching technique. Pull to summit. Get a HA and then save it again. For example, HTIFF. Similar, pick a 16-bit int here. Then it was saved. Inside this folder, there is a HTIFF. There is a LRGB TIFF. Afterwards, we have the option to place it inside our affinity or connection. Then it'll be in 2 TIFF folders. Open now comes the crucial step. We must transfer this HA file. Paste here at this time we have 2 layers. Note that I am using Affinity Photo here. However, for Photoshop the operations are the exact same. It's just my Photoshop subscription. It's too costly. So I purchased Affinity. What about this place? For convenience, name it LRGB. This is named HA. And then, generally speaking, I prefer to put HA below. Put LRGB on top. Next, overlay mode. From normal to screen positive bias. So actually this has been finished. Superposition to some extent HA's mixed color. If we do this now, if HA's layer is hidden, can be found. It is the original image of LRGB. If displayed, it is completely... Color gets weird. mainly due to increased brightness. Saturation seems lower. Avoid looking for now. Regarding color, we'll determine it when displaying this HA. It's equivalent to only this brightness. Mixed into our LRGB completely utilize the brightness of HA, as the brightness of the entire image, in fact, to some extent, just mixed it in. So how do we do it? More precise control. That's also very simple. We create a new layer here. This layer is a curve. Photoshop also has curves. We drag it to HA, only effective for this specific HA. When analyzing this curve, the most conspicuous element within our control is its luminance curve, which plays a crucial role in determining the brightness of the visual output that we perceive. Curve. We only look at its linear form temporarily. It has two sliders, one on the left. Slider starts from 0. One is 255 on the right. Where is the slider? Or one slider, brightness set to 1, slide to 0. When you find it is the original LRGB image, if you slide to 1, you will find it is a picture that mixes HA into the brightness. So this slider, it is identical to the method we employ in pixel math for performing the same task. The one used Q full weight Q when it is 1. Brightness is HA when it is 0. Luminance is LRGB. When in middle, it's an organic mix of 2. Examples can be found. To hear this situation, for instance, when Y is 0.3, this effect is very good. We can conceal the pattern of HA and expose. We'll discover the texture of these dark locations. There is a particular emphasis. As a result, this is the very first usage of it. How to adjust brightness. What's next? A very natural question is, under the traditional pixel math-based approach, we can not only control the brightness, we can control LRB, the relative relationship between RB and the like, to control the mixed-in color. For instance, what is red? Still romantic purple, or sometimes a strange green? These can be achieved. How do we implement this inside? Also, it's simple for curve control. Except for master other than RGB brightness, there are 3 channels, RGB. Control separately. For example, take G and B, slide slider all the way down completely. Only RGB space left. Combine G, B, slide slider down. Only RGB space left. Only leave red. At this time we can see it's equal. We are currently in pixel math. Only the picture is mixed with pure red color. Then you can see at this time the difference between them. Especially in areas with more HAs. You'll see it turn red here. This is the expected outcome. Meanwhile, you can still use the slider to further control the brightness mixed in. To the lowest pass. How much have you mixed? Is it 100% or 50%? You can also control the saturation of this R channel, 100%, saturation, 0% saturation, or between the two. By doing it this way, it has a big advantage. When dragging this slider, you can see the result in real time. Without needing to be like the old pixel math, ask for many formulas and wait for them. After that, the result is not good. Also need to unplug a window. Actually, if it's just like this, if you want a faster method, not particularly worth it. Dedicate a video to talk about it. Actually, if we realize this method, after controlling its brightness and color, we can do a lot more, other more complex, more precise control. As an example, for instance, often when mixing colors, hoping for emphasis. For example, while dragging, we strive to achieve a desired effect. Adjusting brightness slider, we may notice dark clouds in its darker region being emphasized for a more dramatic effect. Highlights emphasized, don't want this. For example, when doing M31, want little red flower. Maybe I just need it temporarily. Mix into a brighter place, don't want to mix in dark places. So for this situation, due to curve, it can't only be straight, but can also add more control points simultaneously, making it a simple method. Just me adding space control. To emphasize specific highlights or shadows, for instance, I will just do one. Such a perverted curve. In this situation, you see mixed color only affects highlighted parts. Dark clouds on dark side have no impact. In this way can be achieved. For example, in the reflective nebula, This dark cloud does not have HA. But if we mix all the HA in, maybe it'll try to govern people again. By doing it this way, let it only mix the highlight part. Achieving selectivity is possible. Organic blending is common. This curve occurs frequently. Don't be as exaggerated as I am. You can also mix a bit of the dark side HA, not black and white. It's a gradual process. Can you do this? It can be done, but it's a little more troublesome. It needs to use range mask first. Take out the brighter parts, then use it to sync for a while. Calm it down, take a break from HA, mix colors with formula. Doable but visible. Use mask, see results. To make it more difficult, adjust by dragging this curve for clear and specific effects. Very flexible. From another perspective. For example, I don't want to mix with the bright department. I want to lift the dark cloud of the dark side, emphasize M42, many in this cloud. Very good comparison and contrast. I just want to highlight this area. You see this bright part. After mixing with HA, it's biased. What should we do? Also simple. The idea is the same. We are present. Highlight the dark portion, then curve once more and remove the bright portion. Just like this. Of course, this may be done now, a bit too exaggerated like this. Then at this time, compare and find the bright part. Actually, no impact, only the dark side's brightness increased. And then this is another kind of way to blend in, way of blending brightness, so we can see when using flexible use of this curve tool. When using brightness curve, we can be very selective adjustment mix high in the end, which brightness range of the image to go. The other question is, if brightness can be done like this, can I do the color like this? Certainly, it is also possible. For instance, we are present in this location. Nonetheless, I just hope to blend in the dark cloud. But like we just did, if we only mix in the dark cloud, like this, if only mixed with dark clouds, you will find that the color of this dark cloud has changed. Especially, for example, we only see this part. The dark cloud's original hue is grey. It's a neutral shade. Or it is a bit dead yellow. What if I mix this hydrochloric acid in? It turned red. Any solution? A method exists. How about yellow color? Return to the RGB curves from earlier. If we take this RGB and bring it to the same height, ensuring that it is at an equal level as the other elements in the composition. Basically, it's colorless. Currently, we can press Alt. Check out this HA once more. Color changed. Why is area black? Because we emphasize dark part. Dark and bright parts set to 0. Then you will find this situation. The color of this piece just became relatively normal. Of course, we can also do some other changes. For example, I don't want it to be this neutral color. I would prefer it to be a kind of, for example, a little bit yellow. Then I can take this blue, pull it down, it turned yellow. Or I hope it's a purple color. It's relatively dark and purplish. Give people a romantic feeling. What about this situation? We pull this green down and it turned purple. So through these things, this color curve, we can control more flexibly again its specific color. But here we've faced another issue. Let's assume we're doing something similar. Uncover the dark side. Color is good. How about highlights? We still want to emphasize it. Don't be like this. There is an additional method. You may have already guessed it. It is these 3 RGB curves. Not only can it be a straight line, it can still make a straight line. Compare curves, become a quadratic curve, etc. For this specific situation, our goal is to achieve a very low saturation of the dark part. Bright part saturation is high. What is saturation? Curve view. Saturation is difference between 3 colors. If the 3 colors are equally bright, saturation is very low. If one color is brighter, then its saturation is high. For this situation, we can put the 3 curves of RGB, add light in dark, add control in dark. This is alpha. Insert control point in dark area, then increase brightness of R in highlight region. Control point not hit. Thus the dark side stays neutral. Highlight allows it to go up. Meanwhile, we may need on this master also add a little bit. Pay attention, if it's excessive there may be fringes. Bright part slightly red, dark part slightly yellow. Control point, this way, just so, selective color processing. Thus, we can clearly see how to utilize this curve tool in the first instance. Reset it. The rightmost slider in white mixing colors that control brightness. The blending of brightness, RGB 3-slider control. Which specific color is being mixed in the process. When we use white slider that is not straight, we have the ability to selectively control. Add more HA, bright or dark part. Similarity when using additional HA is required. RGB type, not a straight line. When discussing curves of color sliders, we can control red, green, and blue. Color of its dark part, color of the highlight, whole process has real-time feedback. In this way, we can achieve, for example, the dark clouds and the dark clouds reflected, coexistence of light, launch clouds during launch. At the same time, it's achievable. Neutral dark clouds, relatively reddish bright areas. So overall, this method is very flexible. The final generated image can be saved as a TIFF file. Further processing in PI, for example, filtering and so on, are all possible. I hope this new technique will be helpful to everyone. Thank you.